Alrighty, everybody. Happy almost weekend, and we're getting close to the holidays. And today, what we're going to do is talk about combining like terms. So, this is the next section in this Mod 6 preview. So, make sure you have your notes, and let's go from here. Okay. This again isn't in your textbook, this is going to be in your packet. Okay. If you want to put that down, and we'll talk about the assignment in a minute. Essential question today, which is same as a learning target. How do I, that's a D, how do I simplify expressions? By combining like terms. So you'll notice that we have some vocabulary here by combining like terms. So I guess we better understand what on earth we mean by a term. So underneath here, sometimes I honestly think it's easier to just show rather than get too wordy. So let's say I have something like this: 3x plus 7y, minus 8, or something like that. Okay? Each one of these items here, the 3x, the positive 7y, and the negative 8, those are each a term. So this one has 3 terms in it. And notice they're separated by positive and negative signs, or addition and subtraction. So I'm just going to put a little separated by plus and minus there. That's how you tell them apart. So you might just have one single term. You could have 10 terms in a giant string. And actually, we're going to simplify some of those today. Woohoo! Like terms. Well, here's what we mean when we talk about terms that are like. That means they're the same in some sort of way. So that would be, let's say, I'm going to take a little detour, so don't write all this down. But let's say, let me get a blank page. Okay, I have 3 apples. This is going to look like a purple apple because that's the color I get on, and I'm too lazy to start changing my color. So I have 3 apples, and then let's say all of a sudden I have, 2 carrots, right? Does that look like a carrot? It's kind of pathetic. People don't even buy carrots that have the greens and the tops anymore, do they? They buy all those little baby carrots because they're easier. All right, and let's say I just have 1 carrot. Okay, and if I asked you, what do you have all together? Well, there might be 4 things there, but carrots. Sorry, that bugs me. Carrot. But it's 3 apples and 1 carrot because they're different. So, yeah, there's 4 things, but they're not really like each other. One's a fruit, one's a vegetable. So like terms in math or algebraically are things like this. If I had 4x minus 12x and a positive 3x, okay? Those are all like terms because they all have the same variable. We could just have constants. Constants mean plain old numbers, like 2 and 19, and I could say I'm subtracting, or I have a negative 100, something like that. Those are like terms. Or maybe I have something like 3b squared plus 19b squared. Those are the same algebraic type of expression, or I should say same type of term, because I have the same variable and they're raised to the same power. So those are like terms. Unlike terms, well, this would be things that simply are different. So something like 4m and minus 3. This is just a constant, or just a number. This has a variable m attached with it. I can't combine those together to be one anything because they're different. They're not like 2x plus 3y. Different letters, different. You cannot combine those into 5 anything. Nope, 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 nope. If I had something like 7, 7j to the third power plus 4j, and you're like, hey, those have the same variable. I'd say, yeah, but that first one has a j to the third power, and this one has just a j to the first power. Sorry, can't combine those together to be 11 anythings. You have to leave them separate because they are not alike. They're not unlike. So if I said simplify this, you'd say, done. It can't simplify it at all. All right. All right. Let's start taking a look now. There's a bajillion, not really. There's a whole bunch of examples, and you're going to say, oh my gosh, it's so much work. All you have to do is determine, are any of these terms like terms? Then I can combine them by adding or subtracting the coefficients. I should have put that term up there too. The term coefficient are the numbers that are in front. And the big thing we're going to talk about is you have to include the sign with it. Excuse me, let's look at these first two. 2y, 3y, like terms. So that just means really you're taking the 2 plus the 3, combining those together, and we're multiplying it by y. Hey, this is kind of like undoing the distributive property that you just did yesterday. 2 plus 3 is 5. 5y. That's it. That's all you have to do. 7m plus 3m. Here's what you're thinking. I have the coefficient 7 and the coefficient 3. I add those together because they're both multiplying the letter m. 10m. 10m. Now, when we are talking about a subtraction, here's how I need you to start thinking of this. You recall when we were doing integers way back there in about module 1, we were thinking this is 5x. Subtraction really means add the opposite. So you can think of this as negative 14x, okay? I want you now, you're looking at this and you're thinking, oh yeah, x, like terms. You just have to think of what's 5 and minus 14. 5 minus 14, or if you like thinking 5 plus negative 14 times x, that's negative 9. That's all you got to do, my friends. Combine the terms that are alike. When there's only 2 of them, pretty straightforward, right? Now, look at this next one. Couple things to watch out for. Look at this first one. There's nothing in front of here. Or is there? Yes, there is. It's a 1. Anytime you see a variable that appears not to have a number in front of it, it's implied that it's a 1. Because 1 times anything is that thing. So, I have a 1n and a 3n and a 5m. Sorry, 5m. You don't have any like terms. So you're just going to come on down and hang out here. And it's a plus or a positive 5. Positive 5. 1n and 3n are like terms. And we're going to simplify by combining those guys together. At this point, you are done. Do you hear my groovy clock in the background? N's and M's are not like terms, so let it be. Now, look in here. I'm like, whew, I got 4 terms here. This one, this one, this one, this one. You can only combine things that are alike. So, here's what I do. 3j, and here's a 6j. Now, in my day, they physically made us do this. They made us utilize the commutative property to say addition can happen in any order. You can switch the order. Here's an 8x, here's a 4x. Because now I can group, now I can use the associative property to throw more parentheses on here. Say add these guys together, 9j. Add these guys together, 12x. That's as much as you can simplify because your variables are different and they are not like terms. Now, I say subtraction signs and I'm going to say, warning, boop, boop, boop. You have to be careful here, all right? You know, there's a reason why we told you subtraction is like adding the opposite, because I don't want you to think of this as minus 12y. I want you to think of this as negative 12y, that you are adding negative 12y. I don't want you to think of this as subtracting 3b. I want you to think of this as negative 3b. This sign sticks like glue to that variable or to that constant 3. Okay? I want you to think negative 3. This minus sign sticks like glue to that 12. If you're a country music fan and you like Sugarland as much as I do, that might bring that song in your head. Whoa, you and me, baby, we're stuck like glue. So I want you to think of keeping that negative sign with it. This 14b, I can use the commutative property as long as I'm thinking of this as all addition and I'm keeping that negative sign with the 12. Okay, I can put this plus 9y down here. I can put this adding of a negative 3b up here. And I can put this adding negative 12y back here. Keep the sign with the number that directly follows it. Okay, all of this is attached and stuck. Now you can combine like terms. Okay, I'm utilizing that commutative property. I'm grouping now and technically with an associative property here, and I get positive 11b. I have a positive 9y plus a negative 12y. That gives me negative 3y. And you know what? If you want to say plus negative 3y, you can. If you just want to leave that as minus 3y, that means the same thing. 11b minus 3y. 11b plus negative 3y. Yes. Ooh, let's get some big ones. Love this. Love this, love this. Okay, negative 16g. I am going to look downstream and look for some more g terms. Whoa, here's one. And it's a negative one. Okay? So bring this negative 7g next. Again, I'm writing it as plus negative 7g. There we go. Now, that negative sign, or that subtraction sign, took that guy. Do you have any more g's? Nope. All right. Now, I have a negative 19f. I'm going to write it as plus a negative 19f. I'm going to look for any other terms that have the variable f, and I have a plus 13f. Okay? Finally, I have this plus 6, which is a constant. That's just sitting there. That's it. Combine the terms that are alike. A negative 16 plus a negative 7. Now, if you're a little rusty with all your integer rules, double check with the calculator just to make sure. Negative 23g. Now you can combine your f terms together. Negative 19 is my coefficient here, positive 13, negative 6f. Okay, I'm just going to write it as minus 6f. If you want to write it as plus negative 6f, go ahead. It's the same thing. This poor plus 6 has no other common or like terms, so it's just going to come on down and join the party here in my expression. That's all you can do to simplify. Look at the next one. Oh, ooh. So I have negative 9a leading the way. And so I've got that one. Now I'm looking downstream for any other a terms plus 9a. Sweet. Okay, got that term. Now I've got some b's. This happens to be a negative 8b. I'm looking for more b's. Here's a plus 2b. Those guys can combine together because they are alike. A negative 7c. Negative 7c minus 7c, and a minus 2c. Keep that sign stuck with the term that comes right after it. All right, my a terms go to 0a. If I have 0 times a, it's just a whole lot of 0. I'm not even going to write any a terms. Combine the b's. Combine the c's. That gives me negative 9c. That's all you can do. Done. Done. Oh, look at this monster. Yes, yes, yes. 8x. All right, so I have a positive 8x. Here's a plus or a positive 4x. Plus 4x. Oop. Now remember, keep this minus sign stuck with that 7x. I'm subtracting 7x, and I want you to think of that like negative 7x. That's it for your x's. Hey, if you want to combine those together right now and bring it on down, go ahead. 8 plus 4 is 12. 12 and minus 7, 5. Let's tackle the y's. I have a minus 6y and a minus 9y. Think of that as negative 6 and negative 9. Or if you like, thinking of subtracting means adding the opposite. That would be negative 6y plus negative 9y. Combine. I have a z. He has no other z's. So my plus 10z is just going to come on down. We didn't have to do any combining. Constants, I have a plus 15, plain old number, plus 4, plain old number. That gives me plus 19. Now this is kind of spread out, so I'm just going to write it so it's more combined more closely. A negative 15y, a positive 10z, a plus positive 19 or plus 19. That's the simplifying you can do. That's it. All right, now let's tackle these. These have some distribution we have to do before. You go ahead and start on these. Distributive property means 3 times A, 3A, 3 times B, plus 7A. Now combine the terms that are alike. As you get better and better at this, you might be able to simply say, I have 3A, include the sign, a plus 7A, that's 10A. And I have a plus 3B with no other like terms, you're done. That's all you got to do. 8G plus 8H plus 3H. Combine. 8G comes on down. 11H. Done. All right, you keep cruising. I'm going to simply work through some of these. I'm going to put a little star here because we've got some negatives to watch out for. You keep moving along as I plow through. Pause the video as you need to. Now notice that 10y, by the way, that wasn't included in the distribution. So don't multiply that guy by 2, just these two. 5 has no friends. I have a positive 2x here and a nope, no other x's. Ha. Almost got confused there. I have a minus 16y and a plus 10y. That would give me negative 6. Done. Negative 6k leads the way. Now I'm going to tell you, hold your horses. Put a squiggly line under that minus sign with the 2. I need you to think of that as negative 2 is getting distributed. Negative 2 times k is negative 2k. Negative 2 times positive 9 is negative 18. Combine the terms that are alike. Done. Ooh, look at all this distribution. 7a, 7b. A positive 9 gives me a plus 9a, positive 9, a plus 9b. Rewrite if you need to show that you're using commutative property, but after a while, you'll just say, here's an A term, here's an A term, and I can do it in my head. Here's a B term, here's a B term. Do it in your head. Boom, boom. 2n. Don't forget that's a 1. Don't try to shortcut not writing this line after you do all your distribution and clean things up. All right, now I might even need to take and rewrite this. I have a 2m because I've got so much going on, and I have a plus 1m, and then I have a plus 2n right there, and a plus 4n right there, and then plain old 12 as the constant. That's as far as you can go. These are all different terms. They are not like terms. Okay? Oofta. Look at this one. Pause the video whenever you need to. Oh, I'm confused here now. Hold on. Eraser. Okay. It's a negative 4 that I'm distributing to a positive 3u. So I've got negative 12u. Sorry. And then I have a 6 that I'm distributing. And that gives you 6 and a 42u. Now combine those terms. So I don't have any other t's. Here's a negative 12u with a positive 42u. Combine those two together. This constant had no other like terms. All right, do this last one. Compare with me once you get everything distributed and see what you have. Oh, I'm running out of room. That's a bad sign. A negative 1w and then a negative 5. Guess what? Nothing's alike. So you're kind of set there. All right, we have a few last ones here. I'm going to have you go ahead and work ahead. This is a ginormous one to work through. I'm going to jump, though, down here to these ones which have algebraic expressions on each side of these. And what I want you to do is find the perimeter and combine these like terms. Okay? You have x plus 5. You have 2x plus 7. And you have 4x plus 1. Take all of your x terms and combine those together. 1x, 2x, 4x. Okay, so I got all those. Then take the constants, the 5, the 7, the 1. Combine those together to get one algebraic expression, 7x and plus 13. This guy, you have all of these sides given in algebraic terms. So we have, I'm going to start with this side. That's a 2x plus 1. You have another 2x plus 1. We have a 1x. We have a 1x plus 1. This is going to be long. Here's another 1x plus 1. And finally, a 1x. You've got to combine all of this together. There's a whole lot of x terms here, aren't there? You have a 2x, another 2x. That gives me 4. Here's a 1x. That's 5, 6, 7, 8. 8 x's. Plus 1, 2, 3. I'm going to go back up here and check this. I think I missed one. Look at that. I did when I was writing all this down. Shame. Yep, I missed a 1 up here somewhere because we should have 4 for our constant. So I'm going to fix that. 2x, 2x, that's 4, 5, 6, 7, 8. All right. So somewhere in that mess, I made a mistake. You make sure you are super accurate as you're doing these. All right. Back up to the giant ones. 9a, 42a. 7 times negative 1 is negative 7. You can combine these guys to be 51a minus 7. Oh my gosh, the giant problem. Distribute, distribute. I think what my problem is I write so big. Okay, put a squiggle line right here with that minus sign and the 4. That's negative 4 times a 5a is negative 20a. This will become negative 4 times positive 7b, negative 28b. Positive 10 times 6a. Positive 10 times 2b. Negative 2b is negative 20b. Now, this is a long string, so I'm going to rewrite this. I have an 8a, that's here. I have a negative 20a, that's there, and a positive 60a. Ouch, it's making my head hurt here. Hold on. Oh, let's see. 8 and negative 20, that's negative 12. Ooh, I think I'm going to do these two first. Negative 20 and a positive 60 is 48. There we go. Oh, you could do negative 12 plus 60. It still gives you 48. Then let's see. Then I had a positive 8b. I had a negative 28b. And I have a negative 20b. Woo! Whole lot of negatives here. These two would give me negative 20b. So another negative 20b would be negative 40b. Oofta! That's a whole lot of great work and a whole lot of fabulous algebra, people. Good for you. Go ahead, your assignment's in your packet. Check Schoology for the pages. And as always, may the force be with you.